Good morning, pilot teachers and students, and good morning, class.
Good morning, sir.
All right, you can take your seat. All right, as you can see, the topic that we will go through in this lesson will be on power. All right, still on the unit work, energy, and power, and we will have a look at power. Now, can somebody or one of you give the definition or explanation of power? Okay. Pilot student, you can also stand up and give your explanation to your teacher on power. Okay, let's have someone from the class to give us a definition. Joe. Power is the All right, let's hear from someone. What is your explanation, the definition of power?
Is the rate of converting energy.
All right, read. Okay, those two answers are quite correct. Both of them are correct. Okay, looking at this power, power is simply the rate at which energy changes, or we can simply put it in other way, which is like the rate at which the work is done. Now, when we consider rate, rate talks about the time. And that is why, according to our formula, power equals to work done divided by the time taken for that work to be done. So here I have the definition of that power. What is power? And those two students have given us, and to the pilot students, probably may have given your definitions to your teacher. Right? Here is the definition. Right? Power is the rate of doing work, or it is the rate of change of energy. All right, after you copy the definition, that is the unit of power. It is measured in joules per second. Right, the work done divided by the time taken, and that will be given as joule per second, or it can be in watts. 1 joule per second is the same thing as 1 watt. Now, the most important point here is that power is a scalar quantity, because the work done is also a scalar, and then you have the time, which is also a scalar quantity. That is why the power should or is always a scalar quantity. All right, that is the unit for power in joules per second. Moving on, right, that is how you can calculate the power, simply the work done over the time taken for that work to be done. All right, another important term given there is instantaneous power. It is also equal to the product of the force and the velocity of an object. So instantaneous power, P equals to F for force times V for velocity. And given below, you can see that. I'd like you to copy that as well. You should be finished. We will move on. All right, given is one example here. Like I will have to explain that quickly. All right, you can classify the cars into different groups or classifications. You can put them on groups. Right, looking at this example given, a Holden Commodore car will take 9 seconds to reach 100 kilometers per hour. It would only take 9 seconds to reach 100 kilometers per hour from rest, okay, when it is starting up. And then you have the racing Commodore of the same mass will take 6 seconds to reach the same speed because of the powerful engine. So we can say that this second, for the second instant here, this should be more powerful than the first one. Okay, a Holden Commodore car, which will take only 9 seconds to reach that. But this one is quite faster and therefore the power quite high, meaning that it is more powerful. Right, when you are calculating power in terms of electrical energy used, you simply use power equals to energy over time, and that energy equals to Q times the voltage. Okay, that is when you are trying to calculate the power from electrical appliances. But for any of these mechanical appliances or appliance, that is how you can calculate the power, the work done divided by the time taken for that. Alright, that is an example of the information given on the instantaneous power, which is force times velocity. I will now give you the activity questions. You can start copying those activity questions, and then I will come back to you for your answers. So, pilot students, your teacher will now ask you to quickly copy those the activity questions down, and then after you have completed those questions, we will discuss the answer to those questions. All right, calculating the force has already been given. The distance is also being given. So you can now use those information to calculate or work out the power. All right, I will now give you question number 2. Please to copy this question quickly. Okay, question 2 and 3 are given there. I want you to also copy those 2 questions and then work on them. right, a few more minutes before you will be asked to give your answers. Pilot students, you can also complete this in time so that we can have a look at them together. So quickly do that. Okay. This Charlie, question 1, and Sarah to question 2. Maureen. Last question, third question will be yours. Huh? Question 2. Why? We don't know. It's very simple. Use the equation there. Power equals to energy over time, and then you calculate. To help her. You finish? You finish? Jolly, you finish? Okay, we are now about to go and have a look at the answers to those 3 activity questions. All right, model students and pilot students, please observe carefully. I will now ask one of the model student to go to the board and then show her working out on the first activity question. Jolene.
The question is asked to find the work exerted by the car on the trailer. So to find the work done, you first have to find the power. You have to find the work done first. So the formula for work is force times distance. So given a force of 100 newtons multiplied by the distance of 300 meters, you get 300,000 joules, and then to get the power. Power is equal to work done divided by the time taken. So 300,000 joules divided by 60 seconds, you have 5,000 joules per second or watt.
Okay, let me see a show of hands for those students who have this answer. Okay, that is correct. If you have 5,000 joules per second or watts, that is correct. We'll have question number 2 now. And I will now ask the next student to all right, you have it.
Since work is equals to force times distance, our work done here is 2,352 joules. So since power is equals to work over time, 2,352 divided by 4 seconds will give you 588 watts.
Okay, 588 watts. 588 should be? Okay, it should be 40 seconds and not 4 seconds. All right, so this one will be 1. 58.8. All right, 58.8 is the answer to question number 2. All right, the last question, Maureen. What have you got?
To find power, we were given the mass, so power is equals to Fs times divided by time. To find the force, we multiply the mass times acceleration, we get 14,700. So force times the distance over time give you the power, which is 36,750 watts.
All right, looking at the answers to the last question, the answer is 36,750 watts. Okay, that is the power. All right, please go through and then check your answers, which is on the board, as well as what is appearing on the screen. All right, the answer will be 36,750 watts. All right, quickly, to recap on what summarize what we have just gone through, power is the rate of change of energy, or you can say that it is a work done or the time taken for that work to be done. Now, we can also see that instantaneous power is simply force times velocity. You cannot really, sometimes you can measure the instantaneous power. Let's say if you want to calculate the power of the engine, you cannot really calculate that. But you can calculate, unless you have the force or you know the force given from the mass and acceleration, and also if you are given the velocity. But power in general is the work done. For example, if you start traveling from here and then go a certain distance and then you take the time, you've done work. But when you take the time that you travel the distance and the work that you did, then you can calculate the power. But sometimes you cannot calculate the power at that instant, like the power of an engine. So it's very difficult for you to calculate that. Unless you have this force and velocity, you can calculate the instantaneous power of an engine. For example, a car. Give an example of a Commodore or Holland Commodore. The one that is used for racing, while the other one that is not used for racing, but you'll find that the power it takes will be higher for the one that takes less time. If it is more, then probably the power will be less. So that is why some cars will be more faster than the others. Just like if you want to calculate the power that you use, instantaneous power, if you are lifting an object, you must know the force that you lift that object as well as the velocity or the speed at which you are lifting. Then you can know how fast you are lifting a weight. Okay, so that is on instantaneous power. All right, in our next lesson, we will study something, or we'll be still on work, energy, and power, and this time we'll be looking at efficiency of machines, and also we'll be looking at pulley system and mechanical advantage. That is what we'll be studying in our next lesson. So with that, our key phrase for our keyword will be power. Okay, our keyword will be power. Good afternoon, pilot teachers and students, and good afternoon, class. Good afternoon, Mr. All right, thank you. You may sit down.